Hello and welcome to the Java and Minecraft modding tutorial. Today we're going to be talking about objects, which are an essential unit of Java. Basically, in Java, the objects are pieces of data that exist in what's called the heap memory of the program. Remember variables like int num equals 1. Remember how these variables, they get created on this line of code and then get deleted at the curly bracket nearest. If I were to put int num equals 1 in another set of curly brackets and then int num2 equals num, this would not work because int num gets deleted at the second curly bracket and now num2 can't access it. Objects, on the other hand, they don't automatically get deleted at the second curly bracket. They actually get deleted when the system, the Java program runs a little, I think it's called a daemon, but basically it's like a little background program called the garbage collector, which picks up objects and throws them in the trash if the objects aren't being used. And objects are declared like normal variables. So this is called a demo object. It's a type, like for example, int was a type, double is a type. So it's just a type I created for the purpose of demonstrating how objects work. So demo obj1 equals new demo obj. Now notice the new keyword here. The new keyword creates a demo obj in the memory. Every object has its own unique type, and this type is called a class. The class file determines what the demo obj has inside of it and how it works. In this case, the demo object gets created, and then once it is created, it actually the program actually instead of this like object, it actually will leave a number here. This number is called the memory location of the object, and demo object doesn't actually store the object; it stores the memory location. The variable obj1 stores the memory location of the new demo object. And the variable obj1 is called a pointer variable. Two variables of type demo object can point to the exact same object. Obj2 and obj1 are both pointing to the exact same number. When you use the variable name just alone, it's referring to the number. So obj1 and obj2 are the exact same thing. However, you can create multiple demo objects. So now obj1 and obj2, they're technically identical in terms of what data they're storing, but they're technically also two different objects at this moment. However, you can also create objects that are different from each other. So for example, demo object is capable of taking in an integer into what's called constructor. The constructor is what creates the object, and I can pass in an integer. You know how you can do system.out.print ln1. In the same way, you can put a 1 in the demo object. Now this demo object has a different data inside of it than this demo object, because this demo object now has a 1 inside of it. Objects have what's known as fields. Fields are basically variables that act as attributes. So variables, for example, you can have a demo object inside of a demo object. You can have int x. You can have not int. You can have an integer variable inside of a demo object. However, the thing that distinguishes fields from normal variables is that they'll exist for as long as the object exists, and they will be unique to each object. So, for example, obj1.mynum is the variable in obj1 which stores a specific value. Notice how I put a 1 here. What this constructor does is it takes the 1 and places it in the value of mynum, which is a variable. So if I print out system.out.print ln obj2.mynum and obj1.mynum, Well, first of all, this line of code will run first, and then this line of code will run second, and they will both print out different things. Because obj1.mynum is different than obj2.mynum because obj1 and obj2 are different objects. Well, they point to different objects. Now, if I run this, oh wait, that's not what's supposed to. Okay, let me just 2. Yeah. So obj1 has a 1 inside of it. Obj2 has a 2 inside of it. Now, fields are like local variables, so I can just set it to. I can set obj1.mynum to 345 instead. Oops. I can set it to 345 instead. And if I run it now, obj1.mynum prints out 345 and obj2.mynum prints out 2 because they don't change. So when do these objects get deleted? Well, they get deleted at systematic times, but they don't get deleted right away. So once the program ends here, the object is not going to be automatically deleted. It'll be deleted once the garbage collector runs, which is usually right after the program ends. It gets deleted when there's no more pointers to an object. Now remember how I was saying that obj2 and obj1 could both point to the same thing? Well, you know what that does? That means that obj2 and obj1 will both have the same exact object. So when I do obj1.mynum equals 345, obj2.mynum also becomes 345 because they're both referring to this demo object. They just happen to have 2 names. Yeah, it's like having 2 names, you know? So if I print out these, they'll both print out the same thing because obj1 and mynum and obj2.mynum are the exact same thing. Now, one more thing that objects can do is aside from storing attributes, they can also do actions. These actions are called methods, and they are called by the name of the method and then parentheses. Calling basically means causing a method to execute, like basically making whatever the method does happen. And in this case, do something just increments mynum. So if I just print out the print, well, it increments mynum, and it also prints out a small statement. And just because obj1 and obj2 are pointing to the same exact object, I'm going to do obj1.do something and send the outer println obj2.mynum. So in this case, it says doing something, and then it increments mynum by 1. Now, you don't want to have too many variables which are pointing to the same object, so I'm just going to do 2 different objects, and this will also make it easier to tell what do something does. Remember, obj1.mynum is equal to 345. When you system.out.println obj1.mynum, you get 345. Obj2.mynum is 124. When you print this, you get 124. Obj2.do something increases mynum by 1. When you print it out, you will get 125. 345, 124, doing something, which is what do something does, but do something also increments 125, increments mynum by 1 and makes it 125. So when you print it out here, it says 125. Now you can create your own types of objects in Java, and notice how I've created the demo obj file here. That is the file for the object I've been using here. But we're not going to play with demo obj. Demo obj is boring. Notice how this project is called Animal Project. That's because we are going to make an animal kingdom, as that's as best as I can describe it. So here we have the class creation dialog. You probably remember this from the first time we opened Eclipse and did stuff. Here, I just uncheck this because it'll confuse you if I keep on checking these. But here, you put the name of the class. Now, important thing to note, names should always follow a certain format. Class names should be nouns. The exception to the class name being nouns is the name of the total project here. This is technically a class file. You could actually create a new animal project if you wanted to, but don't do that. That's bad form. This is a name, and notice how it's camel case. Camel casing means any subsequent word has a capital letter because you can't just put spaces in names in Java. Java doesn't allow spaces. So you also keep the first letter of a class name capitalized. So if I want to create a type of animal, if I want to create an animal class, I'll name it animal. I won't camel case anything because, of course, this is just animal. It's not 2 words. But as you can see, now there's a class file called animal. Now this class file is a blueprint. Think of it as a set of instructions. Whenever Java sees the word animal, it's going to go into this class file. It's going to whenever you create a new animal, Java is going to go into this class file. It's going to check out what animal has, and it's going to run whatever is necessary in animal and create animal. Because we have an animal class file, we can actually create a new animal if we want to do. But since animal doesn't do anything yet, it's kind of boring. So we're just not going to do that yet. Now, the first thing we want to do is create some attributes. So what can an animal do? Well, it can be dead. Private boolean is dead, whether the animal is dead or not. Notice how I said private here. So in the demo object class, mynum was what's known as a public field. I can go here and show you. Public int mynum. However, that's usually bad form. The thing about fields is that they're attributes. You don't want your programmers to be reaching inside of your animal's like soul or whatever and tweaking it so that it's not dead anymore. You don't want them messing with the internal parts of your animal, so you keep it private. Private means that only the inside of this class file can access it. So if you make something private, you'll only be able to access this field from inside the class file. So that means only the animal can make itself dead. Only this class file, the factory that's running the animal, can kill the animal or resurrect the animal, I guess, if you want to do that. Private int food points, private string name. So I'm putting food points here because like animals eat and they lose food points. Like they become more exhausted when they do a lot of stuff. They become hungry. So yeah, I'm just putting that. Animals have a name. Well, I mean, not technically, but they have a name just for the purposes of this, and they have an age, and they have an int x, y. Notice I put a comma here. This is equivalent to writing private int x, private int y. However, it's shorter to just put a comma in between them because they're both integer variables, private int x and private int y. So you can just put a comma between these two names because they're both of the same type, and Java will just initialize them both properly. These are just local variable declarations. However, these variables are created when an object of the animal class is created. So once I create a new animal, and you can call animal Stacy because the animal's name will be Stacy, equals new animal, it'll initialize it'll declare each of these variables in the animal. The animal will now be able to die. It'll have a certain amount of food points, it'll have a name, and it'll have an age, and it'll have an X and a Y. However, since we didn't put any values in these variables, they're going to initialize to default values. For Booleans, default is false. So by default, the animal's not dead. For food points, the default is 0. For integers, the default is 0. So by default, the animal has no food points, which means it should be dead. It has 0 years of age, which makes sense, and it starts at the coordinate 0, 0. For strings, the default value is something known as a null. Null is a memory location, is not a memory location. Most objects are created by putting them in the heap and then returning their memory location to be put inside of this variable. Null is functionally no memory location. Stacy right now is an empty variable. It's just an empty bucket. If I were to try to like system.out.println Stacy, oh, it's loaded, okay. It would print out null. Remember demo obj? Well, oops. If I created a demo obj named b equals new demo equals null, sorry, and I try to call b dot do something, it wouldn't work because there's nothing inside of demo obj. So when I go b dot do something, there'll be a problem because there's nothing to do something. Nothing can do something. It's called a null pointer exception because this variable points to null. Notice the dot here. The dot refers to the memory location. When you get to this dot, the system goes into the memory, it finds the object, and then it does do something. Since null is a null pointer, it doesn't point to anything. The system goes to the memory, it's looking for the object, it can't find anything because it's null, comes back and it just throws an error at you because it's like, I have no clue what you're talking about. Why are you making me do all this work to find a null object? I'm mad at you now. But errors are a good thing, okay? This is a fact of programming. Errors are a good thing. They may look bad, they look scary, but errors tell you where you're failing. Errors tell you your failures, how terrible you are, and how bad you are, and they allow you to improve. Because when you see an error, you know that you can do something. There's a problem and you can fix it. Or there's also times where you're just going to keep on getting errors that have no visible solution, and you're just going to have to stay at your computer and just typing away until you figure out the solution. Yeah, that's annoying. Anyway, now that we've created fields, let's create a method. What can animals do? Well, they can live. Now notice, public. Public means it's accessible outside of the class. So if I create a new animal, notice I put it in parentheses. Parentheses basically are just, they just indicate that they're basically like parentheses in math. It means that do this first, create an animal first. After I create the animal, dot live. Now, this is a method. A method does an action. When the program gets to this, it'll first create a new animal. Then when it gets to the dot, it'll find the animal in the memory, because remember, when you write new animal, it just returns a number. When you do the number, when the program gets the number and a dot, it'll go to memory, find the animal, and then it'll run the live method. When it runs a live method, it'll go in here, it'll find live, and it'll run any lines of code between these curly braces. Public means that it's accessible outside of the animal file. If I made the live method private, we'd have a problem because here it would give an error. The field method live from the type animal is not visible. But it's usually convention to make methods public because you want your classes to be able to do things, right? And since this file, the main method, is what's known as the driver class, which means it's the thing that runs the entire program, your program won't do anything unless you use the driver class to run it. And that's why you make methods public, so that your driver class can run them. Now, public void live. Well, here in live, I guess you can just make it simple enough. System.out.println name plus is living. Of course, notice that name is null right now, but who cares? We'll get to how to give it a name later. And I guess animals' ages increase while they live. So just for the purpose of demonstrating this, I'm gonna make the age integer public so we can print it out. Animal G equals new animal. This animal's name is G, by the way. So it's a lovely name, it's a family name, you know. Then G.live, system.out.println G.age. Just again, for good measure, G.live, system.out.println G.age. So then when you do this, it'll say null, because its name is null, is living. Then it'll print out the age. The age is 1, because when it lives, it grows up by 1 year. Null is living here, and you print out the age, it's 1. It's 2, because it's grown up by another year. And here, age plus plus, remember plus plus increases by 1. The age is increasing by 1 each time you call the live method. Now, public void live, that's a pretty boring method. It just does one thing and it'll always do the same thing except for the fact that the age variable changes between calls. However, what if you want to customize how you use the method? Public void age in here. Method names are always like verbs, as in contrast to variables, which are nouns starting with a lowercase letter, camel case, the second letter. Boolean variables, by the way, are named as questions, so like is dead, for example. But anyway, aside from naming, method names are actions. Aging is an action, right? I can age, you can age, Bob is aging, etc. And now what you can do in age is I can do age plus plus. System.out.println, no, not age plus plus, sorry, age plus equals years. This will increase age by the number of years that's here. And system.out.println, name has aged up to plus age. Now, here's the funny part. Years int years is a variable. It's just a variable. It's declared here, and it'll exist from here until this curly bracket because it's just a local variable. However, you don't see it getting any value, and you don't even see a semicolon either. Where's the semicolon? Where's the value? Well, that is where we get into the interesting part of the interesting part of methods is that you can do something called a parameter. For example, public void eat int food point diff. Food points plus equals food points diff. Now both these methods take in an integer with both these methods have an integer variable here, and this is special because if I want to find my animal here, what I can do is g.age, let's say 13. Now what happens when you get here? Well, first of all, it's this method's called age, so the program will go here and look for a method called age. It'll find one right here. Now there's a number here. The 13, when the program finds this method here, it'll take the 13 and it'll stick it into the years variable. The years is just a local variable, and the program will just insert the value 13 into it. So now this is 13, age plus equals 13. Now when you run the program, look what happens. Null has aged up to 13 because we added 13 to its age. G.age 12. Now it should age up to 25 because we've added 12 to its age. And eat over here also increases food points. And we can do system.out.println name plus has food points food now. Always remember the semicolons. Semicolons are only ever unnecessary after curly brackets. But name has, so eat 234. That's a lot of food. Null has 234 food now because we've eaten. And so that's the thing about methods, is you can put a value as like what's called a parameter. Now you can put multiple parameters. You don't need to just put one parameter. So for example, move int x plus int y plus. Plus, of course, is short for position. Diff is short for difference. This actually, I'm going to call it x diff, like difference, because you move by moving. You don't move by teleporting. So this dot x plus equals x diff. This dot y plus equals y diff. System.out.println name moved to plus x plus comma plus y. And I guess when you move, oh, sorry, why did I write this? Okay, sorry. When you move, your food points decrease, right? Food points minus, right? Because when you move, the more you move, the hungrier you get. So now g.move, 1 to the right, 2 up, or 2, well, whatever direction that is, 2 in the y direction. Null move to 1, 2. G.move, 2, 3. Now, since it's moved to 1, 2, it should move to 3, 5, because, yeah, because it's moving, right? So this is how you declare multiple arguments. You put a comma in between the two arguments. The arguments can be different types. You can make double ydiff to 3.1. Oops. So of course, double ydiff, if I add a double to the integer, it'll just turn into an integer anyway, so it will still return the same value, 3, 5. But you can put the arguments separate, they're called arguments or parameters, separated by a comma, and that works, that just works. Now we get to a topic called overloading. Public void move. Well, you might be saying, why does this have the same exact name? You said that when you call the move method, the program comes here and looks for a method called move. But then it's going to find two move methods and it's going to be confused. Which one do I use? Well, that's where the parentheses come in. The parentheses tell it which one to use. If I just do g.move without any parameters in the parentheses, it will find this move method and run this move method. Not this one, this move method. And from this move method, you can even run this move method if you want to. You can do public void move, move 1, 0. Because when you call this move method, it'll call this move method. A handy little trick, control click will highlight the whatever you clicked on, the original declaration. So if I control click on g.age here, age is the method, it'll highlight the original declaration. Control click, and you can find the original declaration by control clicking. It's just a neat little shortcut. And so I can even control click and it'll take me over here because this is this method. Well, this is a new method. You can even actually call a method from inside itself. I can call move again from inside of move. However, this is ill-advised because when it calls this, it'll be like move. It'll do all of this, it'll come down here, and it'll be like, oh, I have to call this again. Move. It'll do this all again, it'll call me down here, it'll go up here, it'll go up here, go up here, come down here, go up here. It'll be an infinite loop. This is sometimes a good practice, but only if you do it correctly. We're not going to go over that, doing that correctly in this tutorial. Fun fact, it's called recursion. But in any case, avoid using a method name inside of itself unless it's a separate method, for example, distinguished by these parentheses, or it's or you're doing recursion properly, of course. Now, you might be also, no, you might be. Also, one thing to note is that if I created two methods with different parameters, like for example, int x plus, int y plus, I should probably change to int. This would create an error, but why? These have the same name. These have different names, right? They should be. This should work, right? However, methods are searched based on the types of their parameters. These are both ints. Therefore, the program is going to get annoyed that you're making two methods which take in two ints. Because like if you look over here, the name of the method parameters is never given here. The program doesn't know what to do when it gets there, right? So the program won't know what to do when it gets there. So it uses the type of the parameters to distinguish between two different methods. Now, if I take away one of these parameters, the error is gone because now I'm using different types of parameters. This has two ints, this has only one int. Now the program is no longer confused because I can just distinguish them by the amount of parameters they have and the types of the parameters. So you have to be very clear that, okay, methods can have identical names as long as the types of their parameters are different among them. Or methods don't even have to have parameters at all. That's fine too. Now it's time to get into what's called return type. Also, I'm going to delete this because there's no point in making this method. I'm just going to make move without parameters. A return type is this. Java's generic return type is a void. A void method doesn't return anything. So a method's return type is basically, remember scanner? the scanner class we used in the previous tutorial. So scanner is an object, of course, and remember how we could do int input equals scan.nextInt? Well, that is because scan.nextInt has a return type of int, as Java shows you here. The nextInt, basically what happens is that first Java runs nextInt. Then it'll take the return value and stick it inside of this variable, or just basically wherever you put it. So a method with a return type is very important. For example, public void public int get age, for example. Get age can return the value of age. Remember how age is private over here? Well, if we return age using a get age method, we can access age from outside. So the int over here is a return type. Now, when you put a return type in a method, you have to add a statement of return. This return statement is necessary because what return does is it takes whatever its value is here and returns it. Remember how scanner int next equals scan.nextInt. Remember how the number gets replaces this line of code and gets put inside the variable? That's because of a return statement. And a return statement is necessary. You have to have at least one. You have to make sure that there has to exist a return statement. If you just don't put in its return statement, the program will immediately error. See, it'll even just tell you right here. This method must return a result of type int. So this is good for accessing fields. If you don't want people to be able to manipulate fields, but you want people to be able to access them, this is what you do. And fun fact, if you press Control space get, the Eclipse will automatically suggest the names of methods in order to access fields. Oops. Get food points, get name, get x, get y. And if you write is, it'll suggest is dead. These are all getter methods. They're called accessor methods or getter methods, and they just return the value of a field. They're pretty simple. That's all they do. They're not all that interesting, but that's basically all they do. And you can also make a return statement, a method with a return statement, do other things. For example, what if we want to check if the animal has a certain number of, is a certain year, is a certain age? Public Boolean, not check if the animal is a certain age, sorry. What if we want to get the animal's age, but also increment it? For example, not get age, get and increment age into years. So this get and increment age is this age method is a void method, right? It gives it has an int years and then it changes the amount of age to match the years. Well, this would do the same thing as age, right? So you could just call age in here. However, this is also supposed to return the age that we incremented it to. And we can do that with the return statement, return age. So this method will first run age and then it'll return the new age. So let's go over here. Let's delete all this extraneous code and let's do get and increment age. So 12, system.out.println get and increment age. Because notice what this does is it first runs get and increment age. It'll come over here, it'll take the years 12, it'll age up by 12 years by calling this method and coming over here, age plus equals 12 years, and then it's gonna return the age. And once it returns the age, it's gonna put that number here and print it out. So when I do this, it writes 12 because it returns the age. And that of course is pretty important because it allows you to give a value once your method is done running. This is important for Boolean methods. For example, isDead checks if the animal is dead. But we're not talking about if statements and conditions in this video. We're going to talk about that in the video after the next one. So I'm not going to discuss Boolean methods at this moment. But anyway, we can also make a method that takes in another animal, other, because animals eat animals, right? So for one thing, what would happen when an animal eats another animal? Well, the other animal would die. So we need to create a kill method. Kill would of course set isDead to true, wouldn't it? So now, first of all, other.kill. Because we're inside of the animal class, other is another animal object, right? You would pass it into the eat method. But because we're inside of the animal class, you can do other.isDead equals true, even though isDead is a private field. That's because private fields are accessible from inside of the file which they're declared in. They're accessible. So we can do this, but it's better to use methods. Other.kill. Other.kill will kill the other animal. Once the other animal is killed, we can do the other eats method. Remember, the only thing distinguishing two methods of the same name is the types of their parameters. This has a parameter of type animal, and this has a parameter of type int. We can use the other eat method and do eat other.food points, because we're going to claim all the other animals' food points. Now we're going to set the other food points to 0. I mean, it's already dead, so it's a bit overkill. Get it? No. Sorry, bad pun. It's already dead, but I mean, might as well take its food points and subtract it anyway. And we can also do system.out.println name plus 8 plus name, not name, plus other.name, because remember, dot accesses things inside of the object. Dot causes the program to go into the memory, find the object, and then do this thing for it. So now, of course, name is still null. We're going to fix that in a little bit. But when we run, we can create a new animal. So animal G and animal Josie equals new animal. And we can do g.eat Josie. Now, of course, their names are null, so it's not going to tell us very much. But we can do null has 0 food now. That is because over here, eat says how many food points are added. Because both of them have 0 food points, no food points are added. So I guess let's give G some food. Let's give Josie some food points to make this more interesting. Josie.eat 12. So Josie has 12 food points. So once this is over, G should have 12 food points and Josie should have 0. So null has 12 food now. This will first be called, this is called by Josie. Josie first eats 12 food. Null has 12 food now. This is called by G. G.eat other.food points, and now G has 12 food. Null ate null, G ate the other, G ate Josie. And of course, the names are null, but we're going to talk about that now. Just one thing to note, if I want to create a method called public void play with animals, animal other one, animal other two, this works because you can create a method with as many parameters as you want to, as long as they're all different type, as long as any other methods with the same name have the same type. And so you can do that. And I guess what playing with other animals looks like is this dot, not this dot, move, and other one dot move, other two dot move, because when you play you move. But anyway, let's forget about playing now, and we're going to talk about constructors. This is the moment we've all been waiting for. This is the moment when we finally give our animals names. I'm going to create a constructor at the top. Now, a constructor is basically something that allows you to customize how the animal is created, because a constructor is what it's called when the animal is first created. It's basically a method called when the animal is first created. Its return type is the animal that was created. So you don't actually write a return type. You just write public animal. You just write the name, just like that. Now, when an animal is first created, so before we actually create this constructor, animal has what is known as a no args constructor. It's like a method with no parameters. However, once we create our first constructor, so public animal, oops, yep. This no args constructor over here gets replaced by this constructor. And even better, we can also declare maybe the name of the animal upon creating it. So here we have put string name, it's a parameter. Now we're going to get an error. The no args constructor has vanished. We have to give it a name because there's no more no args constructor. Now we've run into a dilemma. This variable is called name, but so is this variable. This is a local variable and this is a field. So that actually means Java actually allows you to do a little special something to distinguish between local variables and fields. And I kept on accidentally doing it because I'm very bad at teaching apparently. But what you do is you write this dot name to refer to the field and name alone to refer to a local variable. The local variable name hides the field variable unless you use this dot. This refers to the object that you're inside of. Dot acts like a dot, acts just like any other dot. So like, for example, Josie.e, it just acts like a dot. Name is the field. This dot name accesses this field. So now we created an animal and it now has a name. When we run this, it should be a lot easier to tell what's going on. Josie has 12 food now. G has 12 food now. G ate Josie because now we've given them names. We can go even further with this, you know, string name, Boolean is dead in case you want to create an animal that's dead upon creation. Int age, in case you want to create an animal that's born in a different age than it should be born in. Int food points, in case you want to create an animal which has a certain amount of food points upon starting. Int x, int y, in case you want to set the animal's position. This dot age equals age. You remember the this keyword. This keyword, use the this keyword over here. Talking about this is so difficult because you have to keep on saying this in common English, but then you keep on saying, but anyway, the this keyword is useful because you can access the field, but you can also use the local variable. Highlighting, if I click control click, it'll take me over here because this is the local variable. Control click, it'll take me to the field because this is the field. This dot is dead equals is dead. This dot food points equals food points. This dot x equals x, y equals y. This dot y equals y. Oops, why did I put a comma there? This dot x equals x, this dot y equals y. And that's how you can set these fields like that. And so now that we've like initialized our animal using a bunch of values, we're gonna get a bunch of errors here because our new animal has a name, only a name. It doesn't, we haven't told it whether it's dead or not. We haven't told its initial age. We haven't told its food points, and we haven't told x and y. Remember method overloading, move, they're both the same method, they're both different methods and they're distinguished by the amount of parameters they have. You can do that with constructors too. Public animal, string name. We can make a constructor which just takes in a name. Now all the errors are gone. However, we could just repeat the code from above. This dot name equals name. This dot age equals 0 because, you know, he started at age of 0. This dot is dead equals false because you're not dead upon birth. This dot food points equals, let's say 200 food points upon starting. This dot x equals 0. This dot y equals 0. We could just rewrite all of that except with arbitrary values, or we could use this keyword in a different way. This, and then we write name, false, 0, 200, 0, 0. What does this do? Well, the this keyword refers to this object. The this keyword also can refer to the constructor. If I click control click, it takes me to this constructor. If I just write this with a parentheses, it's a constructor. Name, false, is dead. 0, age, food points, 200. X, 0, y, 0. Each of these values corresponds to one argument or parameter in the constructor. And this is useful because you can call another constructor from a constructor using the this keyword. Talking about the this keyword is so confusing. But anyway, now we have created an object, an animal. We have created like this amazing animal. Our animal can be created using just a name. Our animal can be created using a series of values. Josie is dead upon birth because poor Josie, she's stillborn. Okay, 0, food point 0, 0, 0. And now Josie is dead, and Josie.eat 12. Of course, Josie may be dead in name, but Josie can still eat because while Josie is considered dead, Josie has not been declared dead by the program. But anyway, now we've created an animal object. Our animal objects can A, be created using an arbitrary amount, not arbitrary, using certain parameters to specify its preconditions. For example, if we put the name parameter, it'll first of all, it'll call this constructor and it'll set name to name, it'll set age to the age you pass in, it'll set dead to the dead you pass in, whether it's dead or not, set food points to this. And all these fields will be set to their correct values. Now we've created fields. Fields are attributes. Usually you make fields private. Don't do what I did. And keeping fields private is good practice because you don't want people reaching into your animal and fiddling with it. We've talked about methods. Methods are just actions, or alternatively, methods can also be getters, which access the values of fields, and they can return values. Returning values is good because returning values allows you to give an output for one method. For example, we can make a method return a field. We can make a method cause an action to happen and then return a value. That's why methods are useful. We learned about I've already gone over everything we've learned. And also remember, important fact to know, Josie can be either a new animal or it can be an existing animal. If I do G and Josie as to the same thing, then when Josie.eat 12 and G.eat, if I do Josie.eat 12 and G.eat 12, I'll be calling eats on the same exact object. G has 212 food now, G has 224 food now because it's calling eat on the same exact object. So that is objects. And next time we're gonna go over inheritance. But as of now, we're gonna welcome to the animal project, and we're going to be continuing this project over the course of the next set of tutorials. I know in the first video that it says inheritance is going to be taught like 3 videos after this one. That's stupid. So I'm moving up inheritance to right after this video. You know, lesson plans sometimes change as you go along. So yeah, and also fun fact, main is a method, but it's called a static method. And a static method is different from an object. We're not going to go over static methods at this moment, but that's a fun fact. If you didn't like this video, you're free to criticize me constructively in the comments. If you liked it, you're free to compliment me in the comments. Constructive feedback is always appreciated, even if you're complimenting me. Please don't insult me. That's not nice. And if you liked it, like it. If you want to subscribe, subscribe. And thank you for listening. Goodbye.